Hello and welcome everyone to yet another tech enthusiastic video from Edureka. I'm Ravi and today I'll be handling C# tutorial. C# is an all-purpose and robust programming language developed by the Microsoft Corporation in the year 2000 as a deadly competitor to Java. It is the most popular and dominating programming language when it comes to both web development as well as desktop application development. In this C# tutorial, we will learn the following concepts. Firstly, we shall begin with C# basics, where I'll introduce you to the C# programming language along with its features. Followed by that, we shall learn the installation procedure for C#. Then we shall understand the C# program structure. Followed by that, the data types, variables, operators, loops, conditional statements, strings, arrays, collections, structure, and functions. Soon after that, we shall enter the object-oriented programming features of C#, where I'll explain you about enumeration in C#, then the object-oriented programming approach such as the encapsulation, abstraction, interface, polymorphism, and inheritance. Then we shall get into overloading and overriding. Followed by that, we shall understand namespace, file operations, events, generics, delegates, and reflection. Once we are done with the object-oriented programming paradigms of C#, we shall enter into the advanced C# concepts, where I'll explain you about the anonymous functions, multi-threading, exception handling, synchronization, and the new features added into the latest version of C#. Once we are done with the advanced programming concepts, we shall wind up the session with the interview questions based on C#. Now, without wasting much time, let us quickly begin with the basics of C#. In the basics, the first chapter is History of C#. Back in the early 90s, Java was the leading programming language for web development, desktop application development, and many other fields. Microsoft wanted to come up with a competitor with many advanced features that can leave Java far behind. It was in the year 2000, Mr. Andreas Eilsberg and his Microsoft team came up with the idea of C#. This initiative was approved by the ISO, International Standards Organization, and also the ECMA, European Computer Manufacturers Association. And finally, the C# enters the world of software development. Now, we shall also understand the features of C# language. Firstly, object-oriented. Object-oriented programming approach is what makes C# to be the most programmer-friendly, easy to develop and maintain programming language. C# is meant to be type-safe. The meaning of type-safe is that the compiler will be given access to only the memory location that has the permission to be executed. This feature improves the code safety to an exponential level. Now the next feature is interoperability. This feature of interoperability makes C# capable enough to do everything that is native to C++ in a more efficient way, which can outperform C++ itself. The next feature is C#'s rich library. C# provides access to multiple number of inbuilt libraries that can provide pre-programmed functionalities to decrease the time spent in the development process. The next feature is C# is scalable and updatable. C# was designed to be superior amongst the other programming languages. Hence, it is always open to updates and it keeps itself highly scalable with its new features. Followed by that, C# is considered to be highly component-oriented. The developers at Microsoft use the component-based approach to develop C#. This is the most predominant development methodology to keep C# highly scalable and updated. Then we have C# to be a structured language. The structured programming approach is preferred during the software development lifecycle, as it becomes easy to develop, compile, and deploy the software compared to other procedural-oriented programming approach. And lastly, C# is considered to be highly fast. C# programming happens to be faster in compilation and execution compared to C++ and other programming languages. These were the few important features of C#. With this, let us move to the next chapter, where we learn about the installation procedures to be followed to install C++ in Windows. To install C++, the first step would be to download the Microsoft Visual Studio. To download Visual Studio, just Google Microsoft VS Code download and open the first link that pops up in your screen. And here you'll find out different links for different operating systems. We have the link for Windows, similarly for Linux as well as Mac OS. Now we need to download a link which is preferred for Windows. Once after the installer file is downloaded, just run it as administrator. You can see that it is unpacking now. Give yes to the permission. Continue. Now your file is being downloaded. Once after all your files are downloaded, you can see something like this on your screen. Here, the most important step is that you need to select the .NET Desktop Development package. Once after you select it, you just have to press install. Now you can see that your Visual Studio is getting installed. Now you can see that your IDE has been successfully downloaded and it's ready to get launched. Press launch button to launch your Visual Studio. Once after you press launch, you can see a new dialog box which will ask you for sign in. If you have a sign in account, you can sign in, else you can just say maybe later. Now you can see a new dialog box. Now here you need to select your development setting as C#. Then select the color theme which you prefer. I will prefer dark. Then you just have to start your Visual Studio. So here, once after you start your Visual Studio, you have 4 different options lying on your right side. The first one, to clone or check out code. Then open a project or solution. After that, you have open a local folder where you might have saved your code. And finally, the create a new project option. Let's create a new project. From here, you have multiple options. You might want to select the first one, then select next. Now here you can name your project. Let's name Edureka project. Let's name our new project as Edureka project. Once after you name your project, select create. Now you can see that your local system is creating your new project. So this is how your first project looks like. Now your Visual Studio is asking for a feedback. You can either give it now or select not now. So this is how your Visual Studio editor looks like. You can see that the Visual Studio has given you the first basic Hello World program, and now let's try to execute it. So to execute your program, you want to select Edureka project, which is the name of your project. Now your program will be executed. You can see that the program has been successfully executed and the output has been printed on the terminal. Now let's continue with our further chapters. After the successful installation of C#, the next project lying in our tutorial for today is the structure of a C# program. The basic structure of a C# program has class, then followed by that the class name. Here we have given it as Edureka. Followed by that we have main function, then the void data type, then the static data type. Followed by that we have the line of string arguments, and then we have the print message. Now let us understand each one of these segments in a much detailed way. Firstly, the class. Class can be generally defined as a keyword that is used to define the class in a C# program. Then Edureka. Edureka is the name of the class. Class is often considered as a blueprint that stores the members and methods related to the class. Followed by that, we have the main. Main is basically the primary method of the whole C# program. It acts as the gateway for the control to enter the program. It gets executed before any other method of the program is executed. Followed by that, we have the void. This segment of the code is designated to the return data type. It can be any data type other than void. Void here means the method does not have any data getting written from it. Followed by that, we have the static. The static keyword, which says the data members declared are static, and a dedicated memory is been allocated for the members declared. Followed by that, we have string arguments. It resembles that the command line arguments that we use in our program. While we execute our program, we basically pass some arguments which will be accepted by the program because of this statement. And finally, we have system.console.written message. So here, the system is the namespace. The console is that the category outlined inside the namespace. The write line is that the static technique of the console category is employed to write a message or the text which is present inside the console. Now, let us move on to the program and see this in a practical way. So here, this is the class keyword which we use to declare our class, and the name of our class is here as program. We can change it to Edureka as well. Then we have the static keyword here, which declares that the data members which are declared inside this particular class are static. Then we have void, which is the return type of the main class. And this particular word is the main, which resembles this is the main function of the whole program. And inside the main function, we have the console, which prints a message that is hello world. So this happens to be the basic structure of a C# program. With this, let us move on to the next part of our tutorial. So the next part of our tutorial is based on the data types we use in our C# programming. So the basic data types used in a C# program are value data types, followed by that we have the pointer data type, and lastly we have the reference data type. Let us understand about each one of these data types in a much detailed way. Firstly, the value data types. The value data types are located in the system.valueType library and are always ready to be directly accessed, and variables can be directly assigned to any particular value. The value data types are further classified into two types. They are predefined data types and user-defined data types. The predefined data types are the ones which we normally use in our day-to-day programming. These data types are predefined by the language developers and are kept ready to use by the programmers. Example, int, float, char, short, double, etc. This particular table here resembles the predefined data types used in our C# program and the range of memory allocated to each data type. Followed by that, we have the memory size allocated to each data type which we use in our day-to-day programming. Followed by value data type, we have the pointer data type. The pointer type is a simple data type. Its functionality is completely similar to pointers used in C programming. They are designed to store the address of another pointer. The example is float *ptr. Now, followed by the pointer data types, we have reference data type. The name is self-explanatory. The reference data type do not actually store the variables. Instead, they store the reference value to the particular variable. In other words, they store the address of the actual variable. The reference variables are classified into three different types. They are object type, dynamic type, and string type. Now with this, let us move on to the next chapter, which is based on the variables we use in C#. Variables are the names allocated for the memory location that store certain data given by the user. And that data is easily accessible by using the variable name. There are basically 5 different types of variables used in C#. They are null, boolean, integer, float, and decimal. Followed by this, let us understand the rules to be followed to declare variables in C#. They are simple. First character should always be an alphabet or an underscore. Succeeding characters can be either digits or letters. Then, special characters are not allowed except the underscore. And the last rule is that the identifiers should not be keywords. Let us see some examples for valid variables that can be used in C#. Firstly, int a. Here, you can see that the variable name is starting with an alphabet. So, this happens to be a valid variable. Then we have int underscore ab. This variable is also considered to be valid because it is starting with a special character, that is underscore. So underscore can be used, but not any other special character. And lastly, we have int a30. Here, the variable name is starting from an alphabet and it is followed by a number. So this is considered to be valid. Then we can see some examples for invalid variables as well. Firstly, we have int 2. So 2 happens to be a number. So no variable name should be starting with a number. So this happens to be an invalid variable name. Followed by that, we have int whitespace b. So the rule says that no white spaces should be included in between the variable name. You can cover that using an underscore, but you should never leave that with a white space. So this is an example for invalid variable. Now after that, we have the last example where int long is an invalid variable name because long happens to be a predefined data type, or you can also consider this to be a keyword So keywords are not allowed to become the variable name. So this is an example for invalid variable names. Now with this, let us move on to the next chapter. The next chapter is keywords. So what are keywords? Keywords are those variables which are predefined in C# libraries and have their own special meaning. For example, you have the keywords for, if, else, main, etc. So all these keywords are having their own meaning. For example, the for keyword is used for the looping conditional statements. Followed by that, you have if, else, main, etc. which come under conditional statements in C#, and main happens to be the starting point of any program in C#. Now let's move further in keywords. So these particular keywords are used in our day-to-day programming in C#, and these keywords are valid since C programming. There are a set of new keywords which are introduced from C#. They are ASM, delete, namespace, protected, throw, catch, public, private, and many more. Now with this, let us move on to the next chapter, which is related to the operators used in C# programming. So an operator can be defined as a special symbol that explains the computer to perform a particular operation, which might be either mathematical or logical, upon a set of variables. C# includes the variety of operators which are as mentioned below. They are arithmetic operators, increment or decrement operators, assignment operators, relational operators, logical operators, and lastly, the bitwise operators. Let us understand each one of those in a much better way. Firstly, we have the arithmetic operators. Arithmetic operators are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Followed by this, we have the increment or decrement operators. Increment operator is used to increase the value of a variable by a specific number, whereas the decrement operator is used to decrease the value of a variable by a specific number. Then we have the assignment operators. Assignment operators are used to assign the values for variables in C++ programming language. Examples for assignment operators are equals to and double equals to. Another example is int a is equals to 10, where the value 10 is been stored into the variable a using the assignment operator equals to. Now followed by the assignment operators, we have the relational operators. Relational operator is a programming language construct or operator that defines the relationship between two or more entities or variables. So the basic examples of relational operators are greater than, less than, equals to, and not equals to. So followed by the relational operators, we have the logical operators. These operators are used to perform logical operations on the given expressions. There are three logical operators in C# language. They are logical and logical or, and logical not. Followed by the logical operators, we have the bitwise operators. These operators are used to perform bitwise operations. Decimal values are converted into binary values, which are the sequence of bits, and bitwise operators work on these bits. So the bitwise operators used in C# language are bitwise and, bitwise or, bitwise not, bitwise XOR, left shift operator, and right shift operator. So followed by the operators, let us move to the next chapter, which is about loops. Now let us understand the loops used in C# programming language. So firstly, what are loops? Loop control statements in C# are used to perform looping operations until the given condition is true. Control comes out of the loop statements once the condition becomes false. There are three types of loops in C#. They are do while, and for. Let's begin with for loop. So the for loop can be defined as a precise loop that has initialization, condition, and lastly the increment or decrement. Now how exactly for loop works? Firstly, you provide an initialization statement, then you have to provide the condition statements based on which your for loop will be working, and finally the increment or decrement operator based on which your condition will be incremented or either decremented. Now to understand this in a much better way, let us go through the flow chart. So this particular flow chart resembles the workflow of for loop in C#. The control begins at the initialization stage. Followed by that, the control enters the condition. Here, the compiler will check the condition, and if the condition is true, then the statements inside the for loop will be executed. And followed by that, the control enters the increment or the decrement statements, where the initialization variable will be incremented or decremented. Followed by that, the control enters the condition again. If the condition is true, this loop will be executed once again. In case if it is false, then the control will exit the for loop. So this is how the for loop works. Now let us execute a basic example to understand this. So this particular example is based on for loop. So here int I happens to be the initialization variable, and this initialization variable is being put under a condition which says I should be less than or equal to 5. And lastly, we have the increment operator on the initialization variable I, which says I++. So I variable will be incremented by one value after every successful execution of the for loop. Now let's execute this example. You can see that the program has been successfully executed, and here is our output. Now with this, let us move ahead to the next type of loop in C#, which is the while loop. While loop can be defined as a loop construct which executes itself repeatedly until a Boolean expression is true. Now let us understand this through a flow diagram. So this particular flow diagram resembles the while loop working. So here the control begins at the condition statement. First, the condition is checked. If the condition is true, then the statement inside the while loop will be executed. Once the statements are executed, the control comes back to the condition again, and the condition is checked. If it is true, the statements will be executed again, else the control exits the condition statement. Now let us execute a basic example to understand the while loop in a better way. So this particular example is based on while loop. Now here the while loop condition is been stated as x should be less than or equals to 10. Until the condition is true, the value of x should be printed here. Now let's execute this program. You can see that the program has been successfully compiled and the output is generated. The values from 5 to 10 are been printed here. So this is how the while loop works. Now let's move on to the next type of loop in C#, which is the do while loop. The do while loop is completely similar to while loop. The only difference is that the condition pops up at the end of the statement. Now let us check out a flow diagram to understand the functionality. You can see that the control begins with a statement. So this statement will be executed first without checking the condition. After that, the control lies up at the condition. Here, the condition will be checked. If the condition is true, then these particular statements will be executed for one more time. In case if the condition is false, then the control will exit the condition. So here we can see that the statements when we use do while loop will be executed at least for once without checking the condition. So this was the functionality of the do while loop. Now let's execute an example to understand it in a much better way. So this particular example is based on do while loop. Now you can see that the condition is been placed at the end of the loop. So the condition states that the initialization variable I should be less than or equal to 10. Now let's execute this program and see its functionality. You can see that the program has been successfully executed and the output has been displayed here, which happens to be the multiplication table of 5. Now let's move further. Now in the next chapter, we will learn about the control statements used in C# programming language. So here, what exactly are control statements? The control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions, to perform tasks repeatedly, or to jump from one section of the code to another. Now the following are the control statements used in C# programming language. They are if statement, if else statement, if else if ladder, then we have the nested if, and finally the switch statement. Let us understand each one of them in a much better way. Firstly, if control statement. If statement in C# language is defined as a programming conditional statement that, if proved true, performs an operation or displays the information inside the statement block. Now, let us check out a flow diagram to understand the functionality of if control statement. So here, you can see the control starts at the start block, and after that it encounters its if condition block. Here, the control checks the condition. If the condition is true, then the statements inside the if block will be executed. Else, the statements followed by the if block will be executed. So this is how the if control statement works. Now let's execute a sample program to understand its terminology. So this particular program is based on if condition, and you can see that here the if condition is specified. Here the number should be less than 5. Until the condition is true, the statement inside the if block should be executed. After that, the statement which is present outside the if block will be executed. Now let's execute this program. You can see that the program has been successfully compiled, and now the output is also generated. Now let's move on to the next type of control statement, which happens to be the if-else control statement in C#. The if-else control statement in C# is defined as a programming conditional statement that has two statement blocks over one condition. If proved true, then the block of statements which are present inside the if block will be executed, else the statements which are present inside the else block will be executed. Now let's see a flowchart to understand it in a much better way. You can see that the control begins at start, then it encounters a condition. If the condition is true, then the block of statements which are present inside the if block will be executed, and after that the loop will be terminated and the control will jump into the next set of statements followed by the condition. In case if the condition happens to be false, then the statements inside the else block will be executed, and followed by that the control exits the condition block and executes the statement which are followed by the condition block. So this is how the if-else control statement works. Now let's execute a sample program to understand its terminology. So this particular program is based on if-else condition statement. Here you can see that I have provided the if condition here. Now if this condition is true, then the statement present inside the if block will be executed. Else, the statement which is present inside the else block will be executed. Now let us try to execute this program and see the output. So you can see that the program has been successfully executed and the number is given the value 12. So the condition here is number should be less than 5, which fails. So the control enters inside the next else block of statements and the message is been printed. You can see that the message is 12 is greater than or equal to 5. This statement is always executed. Now followed by this, let's move on to the next type of control statement, which happens to be the if-else ladder control statement. The if-else ladder in C# language is defined as a programming conditional statement that has multiple if-else blocks. If any condition is true, then the control will exit the if-else ladder and execute the next set of statements. Now let's understand this through a flowchart. You can see that the control starts at the start block, and followed by that, it encounters its first condition. If the condition 1 is true, then statement 1 will be executed and the control will exit the block. In case if the condition 1 fails, then it encounters the second condition. The second condition is executed, and in case if it is true, then the statements 2 will be printed. Else, it exits the block into the next set of statements, which are the condition n. In case if the condition is true, then the statement n will be executed. Else, it executes the default statement which lies after the else if ladder block. So this is how the else if ladder works. Now let's execute a practical example to understand this in a much better way. So this particular example is based on if-else ladder, and you can see the first if condition is been situated here. In case if the condition is true, this particular message will be printed and the control will exit. In case if it is false, then the next set of statements will be executed, and similarly, in case if the second set of statement is false, the third one will be executed. If neither of the statements are true, then the last else block will be executed. So this is how the if-else ladder works. Now let's execute this program. You can see that the program has been executed successfully and the message has been printed here. Now let's move on to the next type of conditional statement that happens to be the nested if control statement. So the next control statement is nested if control statement. The nested if control statement in C# is defined as a programming conditional statement that comprises of another if statement inside the previous if statement. Let us check out a flow diagram to understand this in a better way. You can see that the control begins at the start statement and it encounters the first condition. In case the condition is true, then it will encounter another condition which is lying inside the outer condition. In case if it is false, then the control will exit. Now let us assume that the condition was true. Now the if block, which is lying inside the outside condition, will be executed, and after the execution, it will terminate. So this is how the nested if control statement works. Now let us execute a sample program to understand this in a much better way. So this particular example is based on nested if control statement. Here you can see that I have a first outer if statement present here. Followed by that, we have an inside if condition. So this is how the nested if condition loop works. Now let's try to execute this program and see how does it work. Now you can see that the program has been successfully executed and the output has been generated here. So this is how the nested if condition works. Now followed by this, let's move on to the next type of condition, which happens to be the switch control statement. The switch case in C# is defined as a programming selection statement that checks for the possible match to the provided condition against the available cases. If none of the cases match, then the control will execute the default statement. Now let's check out the flowchart. You can see that the control starts from switch expression. So switch expression is the block where we provide our condition. Once after the switch expression is executed, the control will enter the cases. So inside the cases, it will find a match. In case case 1 is matched, then the statement 1 will be executed. Similarly, in case if case 2 is matched, then statements 2 will be executed. If any of the cases doesn't match, then the control will directly enter the default statements and the default set statements will be executed and the control will terminate the switch statement. So this is how the switch control statement works. Now let's try to execute a program. So this is an example for switch control statement. Now let's try to see the condition. So this is the statement where we provide the condition, and inside this, the control will try to find out a match. Now let's try to execute this switch control statement. You can see that the statement is being executed. Now the output terminal is asking me to provide an input. Now let's try to provide an input which is a vowel. So you can see that it found the possible match and the output has been generated now. So this is how the switch control statement works. So followed by that, we shall move into our next chapter, which deals with strings. So string is defined as a one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as words or sentences. Each character in the array occupies 1 byte of memory and the last character must always be 0. Now there are a set of string functions available in C#, out of which the important ones are clone function, which returns the reference of the string. Then we have compare, which compares two specific strings. Followed by that we have string concat, which joins two strings and stores the result in the first string. Then we have contains, which returns the value of a specified substring. Then we have copy2, which copies the characters from one position to another. Then equals, that determines the two string objectives have the same value. And lastly, we have trim, which trims the strings. Now let us execute a sample program to understand strings in a better way. So string happens to be completely similar to that of arrays. We will deal with arrays in the next chapter. So what are we trying here is to store the values, which are the string values, into this particular character array. Now the string we want to store is Edureka C# tutorial. Now let's try to execute this program and see the output. You can see the program has been executed and the output has been generated, which is Edureka C# tutorial. Now let's move into the next chapter, which happens to be the arrays. So an array is defined as a collection of similar type of data items stored in a continuous memory location. The array is the simplest data structure where each data element can be randomly accessed by using the index number. There are three different types of arrays, namely one-dimensional array, two-dimensional array, and multi-dimensional array. Now, let us understand each one of them in a much detailed way. Firstly, one-dimensional array. One-dimensional array can be defined as an array with single row and multiple number of columns. The 1D array can be accessed using their index numbers. Here, I have declared an array with the name myArray, and the values it will be storing are integer type, and it will be storing 5 different values. Now let us see how does it work. You can see that my first element is 10, and this element will be stored in the first memory location of an array, which is 0. So this is called as the index of an array. So we have 5 indices for my array, which are 0, 1, 2, 3, and 4. Now the element 10 will be stored in the first location, which is 0. Now followed by that, we have few more elements which are 20, 30, 40, and 50, which will be stored in a continuous order from 1 to 4. So this is how the arrays work. Now let us execute a sample program based on one-dimensional arrays. So this particular example is based on one-dimensional arrays, and my array name is ARR. Now I'm trying to store 5 different elements into my array, which are 10, 20, 30, 40, and 50. Now let's run this. You can see that the code has been successfully executed and the array has been printed here, which is 10, 20, 30, 40, and 50. Now with this, let us move on to the next type of array, which happens to be the two-dimensional array. The two-dimensional array can be defined as an array of arrays. The 2D array is organized in form of a matrix, which can be represented as a collection of rows and columns. The elements of an array are accessed using the intersection coordinates. Now, let us see the working of two-dimensional arrays. Here, you can see that I have declared an array with the name array. Now, you can see that the index values are changed. The first index is 0, 0, which happens to be the row number 0 and column number 0. Similarly, we have all the other elements with their intersection coordinates. Now let us try to include elements into my two-dimensional arrays. The first element is 10, which will be loaded to the first location, which happens to be 0, 0. Then let us include few more elements into my two-dimensional array, which are 20, 30, 40, 50, 60, 70, 80, 90, and lastly 100. You can see that the elements are stored in the two-dimensional array in a continuous order. So this is how the two-dimensional arrays work. Now let's try to execute a program to understand their terminology in a much better way. So this example is based on two-dimensional arrays. Now you can see that we have two different for loops. The outer for loop is dedicated for rows and the inner for loop is dedicated for columns. Now let's try to execute this program and see the output. You can see that the program has been successfully executed and the elements have been added into my array. Now let's move on to the next type of arrays, which are the three-dimensional array or the jagged array. The multi-dimensional or three-dimensional or jagged array is defined as the array of arrays. The 3D array is organized as a 3D matrix, which can be represented as the collection of multiple rows and multiple columns. The elements in the array are accessed using 3D intersection coordinates. Now let us try to see an example and understand how does it work. So this particular example is based on jagged array. Now let's try to execute this and see the output. So you can see the code has been successfully executed and the elements have been added into my array. So this is how the jagged array works. Now let's move ahead and understand collections. So what are collections? Collections can be simply considered as a group of objects collected so as to apply some functions upon the collected data. The operations that can possibly perform on a collection are store object, update object, delete an object, retrieve an object, search for an object, and sort the object. Now moving ahead, the types of collections. There are three different possibilities to work with collections. The three namespaces mentioned are system.collections.generic classes, system.collections.classes, system.collection.concurrent classes. So the first type of collection is list. The list is considered as a data structure available in system.collection.generic's namespace. It can store and fetch elements. The list is capable to store duplicate elements as well. Now, let us try to execute a sample program to understand list in a much better way. So this particular example is based on lists. Now here, I'll be adding 4 different names into my list. Let's run the program and see the output. You can see that my 4 different names are being collected into my list. Now in the collections, the next one is the linked list. So what is a linked list? Linked lists are linear data structures similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory location. Instead, they are stored in random addresses and they're connected using pointers. So we have 3 different types of linked lists in C#. They are singly linked list, doubly linked list, and circular linked lists. Now moving ahead, let us understand how does linked list work. Imagine that you have to store 5 elements, and in case if you're using array, then the compiler will assign 5 blocks which are stored in a continuous memory allocation, and the size would be fixed, and the elements will be stored in your array. But in case of linked list, if you had to store the same 5 elements, then the compiler will select random 5 blocks from the memory heap, and it will assign you the 5 memory blocks you needed for your data. So here you have 5 different elements, 10, 20, 30, 40, and 50. And the compiler has given you 5 different memory blocks, which are the following. You can see that each memory block is having one blank space and the other one is having an address. So this particular address is a pointer which points to the next upcoming node. So similarly, all the blocks have their own pointers. Now let's try to store the elements into our linked list. So you can see that the elements have been stored successfully into our memory blocks, and there is a small change in the last. You can see that the last node is not having any pointer here. Instead, it is storing a null value. This indicates the end of the linked list. Now all these linked lists are interconnected using their pointers in this way. So this is how it acts as a continuous memory, being a non-continuous memory. So once after the linked list get connected, so this is how it looks like. We have a head, we have a tail, and the nodes in between. Now that we have understood the terminology of linked list, let us deal with the types of linked list. Firstly, we have singly linked list, then we have doubly linked list, and finally the circular linked list. Let's deal with the singly linked list first. You can see this particular node is the head and this one is the tail, and between we have the nodes. So what exactly a singly linked list is? A singly linked list contains 2 fields. Firstly, the address node, and the next node is the data assigned to the present node. The singly linked list is capable to traverse only in one single direction. Now let's try to run a program based on singly linked list. So you can see that this particular example is based on singly linked list. Don't worry about the code. If you want the code at any point of time, we can mail you if you provide your valid mail ID to us. Now let's try to execute this program and see the output. You can see that the program has been successfully executed, and we also traversed the linked list, and meanwhile we tried to delete the elements 11 and 14 from our linked list, and after deleting the linked list we again traversed the linked list and the result is been displayed here, which are 12, 13 and 15. Now after this, let's move on to the next type of linked list, which is the doubly linked list. A doubly linked list, the nodes contain 3 different fields, namely the address of the previous node, the data to be assigned, and the address of the upcoming node. Now let's try to execute an example based on doubly linked list. So this particular example is based on doubly linked list. Now let's execute this and see the output. You can see that the doubly linked list has been successfully executed and the output is been displayed here. Now followed by this, let's move on to the next type of linked list, which happens to be the circular linked list. There is no much difference between the singly linked list and the circular linked list, but the only difference that we have is the tail is connected to the head again. In case of singly linked list, the tail node's address block was supposed to be replaced by a null character. But in case of circular linked list, the address block of the tail node is replaced with the address block of the head node. So that's how the head and tail get connected and the linked list performs as a circular linked list. Let's execute an example based on circular linked list to understand its terminology in a better way. So this particular example is based on circular linked list. Now let's execute this and see the output. You can see that the circular linked list program is been successfully executed and the output is been displayed here. Now let's move ahead and understand the next type of collection, which happens to be the stack. So what is a stack? Stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, which is last in first out, or FILO, which is first in last out. Let's understand this terminology through an example. You can see that I have declared a stack by name myStack, which is completely similar to that of an array. Now let me try to add some elements into my stack. So the terminology first in first out is, if you try to add in an element, then the element gets added to the first location, which is 0. And after that, if you add few more elements into the stack, that is to 1, 2, 3, 4 and 5, and your stack is full, then if you want to access the first element, then you need to pop all the elements above the first element. Only then you can access the particular element you wanted to access. Let's check out the example and see how does it work. The first element is 10, which will be loaded to the first position 0. Similarly, let me add few more elements, which are 20, 30, 40, 50. Now let us assume that I need to access the element 10. Then I need to pop 50, 40, 30, 20, and finally I'll be able to access 10. So this is a terminology called first in, last out, or last in, first out. So 50 happens to be the last element. So this is the first element that will be coming out. Now let's see how does it work. You can see 50 popped out first, then 40, similarly 30, 20, and finally we have element 10, which is popped out in the last way. So this is how the stack works. Now let's execute a basic example to understand the terminology of stack in a much better way. So this particular example is based on stack. So the elements that I will be adding into my stack are the names which are provided as below. Now let's try to execute this program and see how does it work. You can see that the elements have been successfully added into my stack, and I tried to remove the element Kumar, then I popped Kumar. After popping Kumar from my stack, we have Rajesh. Similarly, after popping Rajesh, we'll be having James, we will be having Pooja after popping James, then finally we'll be having Chandan. So this is how stack works. Now let's continue and understand the next type of collection, which happens to be the queue. A queue is a linear structure which follows a particular order in which the operations are performed. The order is first in, first out. This is opposite to stack. In stack we had first in, last out, but in queue we have first in, first out. Let's see how does it work through an example. Now here, completely similar to that of stack, I have declared a new queue with name myQueue. Now I'll be trying to add in elements into the queue. So the first element will be stored in the first location 0, followed by that 1, 2, 3 and 4. Let's try to add some elements into my queue. The first element 10 has been successfully added. Then we have 20, 30, 40 and 50. So these elements will be stored in continuous memory locations. Then if you try to access 10, then you can directly remove 10 from the queue, which is first in, first out. But in case if you want to remove 50, then you have to wait for 20, 30, 40 to be removed. So this is how queues work. Let's see practically. Let us think, or let us assume that we want to access 50 from the queue. Then we have to remove 10 first, followed by that we have to remove 20, then we have to remove 30, later 40, and finally 50. So this is how the first in, first out works, or the last in, last out works. So the 50 element was the last element to be coming into the queue. So similarly, this is the last element that is to come out from the queue. So this is how queues work. Now let's execute a sample program to understand queues in a much better way. So this example is based on queues, and similar to stack, I'm trying to add names into my queue. Let's execute this program and see the output. You can see that the elements have been successfully added into my queue. Then the peak element was Srujan. So Srujan is the topmost element, and we have dequeued Srujan. After dequeuing the peak element, we have Prajat as the next peak element. With this, let us move to the next kind of collections, which is the hash set. So what is a hash set? The C# hash set category is often accustomed to store, take away, or read components. It does not store duplicate components. Now let's try to execute a sample program to understand hash set. So this particular example is based on hash set. Let's run this program. You can see that the program has been successfully executed and the elements have been successfully added into the hash set. Now let's move further and understand what are sorted sets. The C# sorted set is often accustomed to store, remove, or read elements. It maintains ascending order and does not store duplicate elements. It's prompt to use sorted set category if you've got to store distinctive components and maintain ascending order. It's found in system.collections.generic namespace. Now let's execute a sample program to understand sorted sets. So this example is based on sorted set. Now let's execute this. You can see that the program has been successfully executed and the elements have been added into the sorted set in ascending order. You can see that the names provided were Sanjay, Anuradha, Praveen, Ravi and Kajal, which are not in an ascending order. When you executed the program, the names were in ascending order, which were Anuradha, Kajal, Praveen, Ravi and Sanjay. Now let's move ahead and understand next type of collection, which happens to be the dictionary. Dictionary category uses the idea of hash table. It stores values on a premise of the key. It contains distinctive keys solely. By the assistance of the key, we will simply search or take the elements away. It's found in the system.collections.generic namespace. Now let's execute a sample program based on dictionary. So this particular example is based on dictionary. You have the keys which are 1, 2, 3, 4 and 5 and their respective elements which are Shiva, Preetham, Roy, Akash and many more. Now let's execute this and see the output. You can see that the program has been executed and the elements are stored according to their keys. 1 for Shiva, 2 for Prasad, 3 for Preetham, 4 for Roy and finally 5 for Akash. So this is how the dictionaries work. Now followed by that, the next type of collection is the sorted dictionary. So what is a sorted dictionary? The sorted dictionary category uses the conception of hash table. It stores a value on the idea of the key. It contains distinctive keys and maintains ascending order on the idea of the key. By the assistance of the key, we will simply search or take the elements away. It's found in the system.collections.generic namespace. Now let's execute a sample program to understand sorted dictionary. So this particular program is based on sorted dictionary. Now let's execute this and see the output. You can see that the numbers or the keys have been given in an irregular manner. Now let's see the output after executing. You can see that the program has been successfully executed and the elements are sorted in an ascending order. So this is how the sorted dictionary works. Followed by this, we have the next type of collection, which happens to be the sorted list. The sorted list is an array of key value pairs. It stores the values on the premise of the key. The sorted list category contains distinctive keys and maintains the ascending order on the premise of the key. By the assistance of the key, we are able to simply search or remove the elements. It's found in the system.collections.generic namespace. Now let's execute a sample program to understand sorted list. So this particular program is based on sorted list. Now again you can see that the keys are given in a random order. Let us execute this program and see the output and what are the changes that we can find in the output. You can see that the program has been successfully executed and the output has arranged all the elements in the ascending order based on their keys. Now followed by this, let's move ahead into our next chapter, which happens to be structures. So what is a structure? A structure is defined as a user-defined data type available in C# that allows to combine the data items of different data types together. Structures are used to represent a record. Struct is a keyword used to declare structures. The basic example of a structure is been given below, which is declared using the keyword struct, and the name of the structure happens to be school. And inside the school, you have ID of integer data type, then you have the name, which is of string data type, and finally the percentage, which is a float data type. So all these keys are belonging to a different data type and they are collected under one structure, that is school. So this is how structures work To understand structures in a much better way, let's execute a sample program. So this particular example is based on structures. Here, my structure is books, and inside the books, I have title, author, subject, and book ID. Now let's try to execute this program and see how does it work. You can see that the program has been successfully executed and the output has been generated here. So followed by structures, we have functions. So what exactly are functions? A function is defined as a block of code of the main code. The function is used to execute statements specified in the code block. A function consists of the following components, which are function name, return type, body, access specifier, parameters. The function name is used to make the function call. Then the return type, which specifies the data type of the return value, and followed by that the body, which contains the executable statements. Then we have the access specifier, which specifies the function's accessibility. And finally the parameters, which are the list of arguments. Now let's see an example to understand functions in a much better way. So this particular program is a basic example of functions. Let's execute this and see how does it work. You can see that the program has been successfully executed and the data has been displayed here saying inside show function and the message welcome to Edureka. Now let's execute few more examples based on call by value and call by reference. So this example is based on call by value. We know that the functions execute basically by two means, which is call by value and call by reference. So this is the first type, which is call by value. Now let's run this program and see the output. So you can see that the program has been successfully executed and the output has been generated now. And the next type of functions, which is call by reference. Now this type of program is based on call by reference. Let's execute this and see the output. So you can see that the program has been successfully executed and the output has been generated. Don't worry about the codes, we can send you if you provide us your mail ID. In C# we also have another type of function, which is out parameter. Now let's execute a program based on that too. You can see that this is the program. Now let's run this. There you go. The program has been executed and the output has also been successfully generated. Now with this, we conclude the basic part of our C# tutorial. So now we begin with the object-oriented programming in C#. Object-oriented programming system is a programming paradigm based on the concept of objects that contain data members and methods related to them. The primary purpose of object-oriented program is to increase the flexibility and maintainability of programs. So now we shall discuss some of the features of object-oriented programming. It emphasizes more on data rather than procedure. The programs are divided into objects, thus making it easy to work with. Data structures are designed in such a way that they characterize the objects. Functions that work on the data of an object are placed together in the data structure. Data is hidden and cannot be accessed by external functions without permission. Communication between objects can take place with the help of functions. Adding new data and functions has become easy. Follows the bottom-up approach in programming design. So all these features make the object-oriented style of programming the most reliable style of coding. So with this, let us begin with the first approach of object-oriented programming, which is encapsulation. So what is encapsulation? Encapsulation is a procedure to combine the methods along with their data members. Now, let us go through a sample program to understand encapsulation in a much better way. Now, this example is based on encapsulation. So the main motto of encapsulation is to combine the methods along with their data members. So this one example is based on encapsulation. Let's execute the code and see the output. Here you go. The code has been successfully executed and the output has been displayed here. Now let's move on to the next part of object-oriented programming, which is the abstraction. Abstraction is a method to hide complex coding part from the user by providing him with only the required information he needs. Now let us execute a program based on abstraction to understand this in a better way. So this particular program is based on abstraction. Now abstraction is a procedure in which you hide the unnecessary information from the user and help him to get the information only which he is looking for. Now let us execute this program and understand how does it work. You can see that the program has been successfully executed, and the related information which the user was looking for is the brand of the laptop and the model name, which has been displayed here. Now after this, let's move ahead and understand interface. The interface is completely similar to abstraction. The functionality of interface is to hide the unimportant data from the user and provide him with the only important data he needs. Now, let us also execute an example based on interface. So this particular example is based on interface, and we declare an interface using the keyword interface. Now, let us execute this program and see the output. You can see that the program has been successfully executed and the output has been displayed. Now with this, let us move ahead into the next part, which deals with polymorphism. Polymorphism is a combination of two words, which is poly and morphos, which means many forms. It is a Greek word. It means the code segment can take up multiple forms. We have two types of polymorphism, namely compile time polymorphism and runtime polymorphism. Now let us execute a sample program based on polymorphism. Now this particular program is based on polymorphism, and here we have two functions with the same name, that is add numbers and add numbers again, but the only difference is the first add numbers function has two parameters and the next add numbers function has three parameters. Now from the main class we are providing the parameters 1 and 2 and another function call which provides the parameters 1, 2 and 3. So the functions will be called based on the number of parameters we are calling with. Now let's execute this program and see the output. You can see the functions are called and the output has been displayed here. With this, let us move ahead and understand the next part, which is inheritance. Inheritance is a process in which one object acquires all the properties and behaviors of its parent object automatically. You can reuse, extend or modify the attributes and behaviors which is defined in other class. The class which inherits the members of another class is called derived class, and the class whose members are inherited are called as the base class. The derived class is the specialized class for the base class. Now there are varieties of inheritances available in C#. Firstly, we shall deal with single level inheritance. C# single level inheritance is a process where a subclass inherits all the properties and behaviors of a single superclass. Let us check out an example to understand single level inheritance in a better way. So this particular example is based on single level inheritance. The first main class or the base class is the user, followed by which we have details class, which happens to be the subclass. Now let us execute this program and see how does it work. You can see that the program has been successfully executed and the properties of the base class are being inherited into the child class. Now let's move ahead and understand next type of inheritance, which happens to be multi-level inheritance. So the multi-level inheritance is a process where a subclass inherits all the properties and behaviors of more than one superclass at multiple levels. You can see that this particular class A happens to be the base class, followed by that this class happens to be the child class for class A, and finally you have class C, which happens to be the child class for class B. So here class C is inheriting the properties of class B and class A. Let us execute a sample program to understand this in a better way. So this particular example is based on multiple inheritance. You can see that this particular class A happens to be the base class, and followed by that we have the class B, which happens to be the child class to class A. Then finally we have class C. So this particular class C is the last child class. Then here we can see that class B is inheriting the properties from class A. Similarly, class C is inheriting the properties from class B. Now let us try to execute this program and see the output. So you can see that the program has been successfully executed and the output has been displayed. So followed by this, we can move on to the next type of inheritance, which is hierarchical inheritance. Hierarchical inheritance is a process where one or more subclasses inherit all the properties and behaviors of one superclass. Now, let us try to execute a basic program to understand the hierarchical inheritance. So this particular example is based on hierarchical inheritance. Here we have different classes. Firstly, we have the class principal, and followed by that we have the class teacher. Then lastly we have the class student. So here the properties are being inherited from principal to teacher, then teacher to student. Now let's execute the program and see the output. You can see that the program has been successfully executed and the output has been displayed on the monitor. Followed by that, we also have few more types of inheritance, such as multiple inheritance and hybrid inheritance. But C# does not support multiple inheritance as well as hybrid inheritance. Moving ahead, we deal with overloading. When we create two or more members of a class having same name but different number or type of parameters, then it is known as C# overloading. In C#, we can overload methods, constructors, and index properties. Now, let us try to execute a basic example to understand overloading in C#. So this particular example is based on function overloading in C#. We have two different methods here with the name addNumbers and addNumbers. So one of the addNumbers method has two parameters and the other addNumbers method has three parameters. Now let us try to execute this program and see the output. You can see that the program has been successfully compiled and the output has been generated here. With this, let us move on to the next chapter where we'll deal with overriding. When a derived class has a function with the same name as a function of the base class, then this is called as function overriding. Both the functions must have the same number of parameters in both the classes. Let us try to execute a sample program based on function overriding in C#. So this particular example is based on function overriding. So we have a method called as getInfo in the base class, as well as another method with the same name, which is getInfo in the derived class. And both the functions have zero number of parameters including in them, and they also perform the same operation, that is to print a message in the terminal. Now let us try to execute this program and see the output. You can see that the program has been successfully executed and the messages are also printed on the screen. Now with this, let us move ahead and understand the differences between overloading and overriding. The first difference, the scope is same in overloading. When it comes to overriding, the scope is different. The next difference is, in overloading, the signatures must differ, while on the other hand, in overriding, signatures must be the same, that is, the number of parameters. Followed by that, the third difference is, in overloading, multiple overloading functions is possible. In overriding, multiple overriding functions is not possible. The last difference between the both is, overloading can occur without inheritance, but on the other hand, overriding occurs only because of inheritance. With this, let us move ahead and understand enumeration in C#. So what is enumeration? The enumeration in C# is a user-defined data type. It is designed to assign names to integral constants. The names increase the readability of the program and also the program becomes easy to maintain. Now, let us see an example based on enumeration and understand that in a much better way. So this particular example is based on enumeration. You can see that my enumeration name is week and I've declared this enumeration using the keyword enum. So here I'm inputting some data into my enum, which is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So these values which I have entered into my enum week will be considered as constants and these values will not be changed. You cannot remove any elements from this particular enum, but you can try to add in some values into this enum. In this particular instance, you cannot add more elements into this particular enum as every week has 7 days. But in other instances, you might add in some new values into your enum but cannot remove the elements. Now let us try to execute this program and see the output. You can see that the program has been successfully executed and the output has been displayed on the screen. So according to the program, I was supposed to print the position of the constant Friday in the enum, so which happens to be 0, 1, 2, 3, and 4. So Friday comes at 4 and the data is being displayed on the monitor. So this is how enums work. Followed by this, we shall move ahead and understand namespace. So namespace is basically used to handle multiple classes present in the program. The namespace is available in different ways. System.console. Here, the system becomes the namespace. Then, to access the class of a namespace, we need to use namespace name.className. And finally, we can use the keyword using as well. To understand namespaces, let us execute a sample program. So this particular example is based on namespace. And now here we are trying to print two different messages, which are welcome to Edureka and happy learning. Now let's try to execute this program and see the working. You can see that the program has been successfully executed and the output welcome to Edureka, happy learning has been printed here. Now let's move ahead and understand file operations in C#. The file mode is an enumerator which defines multiple file opening methods. The members of the file mode enumerator are described as follows. Firstly, append. It opens an existing file and puts the cursor at the end of the file or creates the file if the file does not exist. Next, create. It is designed to create a new file. Followed by that, we have create new. It is designed to specify the operating system that it should create a new file. After that, we have open. It is designed to open an existing file. Then we have open or create. It is designed to specify the operating system that it should open a file if it exists. Otherwise, it should create a new file. Then truncate. Truncate opens an existing file and truncates the size to 0 bytes. Now followed by this, we shall understand the file operations in C#. The file operations in C# are reading data, which is read, then writing new data, which is write, and finally we have read and write. With this, let us understand file share enumerator. The file share enumerator is used to share a particular file. It has the following members. Inheritable. Inheritable allows a file handler to pass an inheritance to the child process. Next we have none. None declines sharing of the current file. Then we have read. Read allows opening of a file for reading. Then we have read write. Read write allows opening of a file for reading and writing. And finally we have write, which allows to open a file and write. Now let us continue with events. An event is generally known as an action that is generated by the user. It might be a click from the mouse or even a single keystroke from keyboard. Similarly, C# programs also have events. The generator of the event is called as the publisher and the receiver of the event is called as a subscriber. Let us try to execute a sample program to understand events in a much better way. So this particular program is based on events. Class event block is known as the event block. Then we have the subscriber, which is welcome user. Now let us try to execute this program and understand the functionality. You can see that the program has been successfully executed and the messages are also printed here. Welcome to Edureka, happy learning. With this, let us move on to the next chapter, which deals with the generics. So what are generics? Generics is the concept of providing the members and methods of a class with placeholders in runtime. We can define generics using greater than less than brackets. Let us check out the following examples. Firstly, let us execute an example based on generics in a method. So this particular program is based on generics in a method. Now let us try to execute this and see the output. You can see that the program has been successfully executed and the message was from generic class, and the message from generic class is 123E. Followed by this, we shall execute an example based on generics in a class. So this particular example is based on generics in a class. Now let us try to execute this and see the output. You can see that the program has been successfully executed and the message has been printed. This message is from generic method and the message is 321H. Followed by this, we shall move into the next chapter, which deals with the delegates. So what are delegates? A delegate acts as a reference to the method. Basically, it is same as the function pointer in C and C++, but far better and type safe. The delegate in static method encapsulates method only, while the delegate in the instance method encapsulates both method and instance. The best use of delegate is to use it as an event. Now, let us execute a sample program based on delegates. So this particular example is based on delegates. Let us try to execute this and see the output. You can see that the program has been successfully executed and the output has been displayed. Now with this, let us move on to the next chapter where we can deal with reflection. So what exactly is a reflection? The reflection is required to obtain the metadata in runtime. The reference is available in system.reflection namespace. Now, it requires the following classes to execute. They are type, member info, constructor info, method info, field info, property info, type info, event info, module, assembly, assembly name, and pointer. Now let us execute few programs based on reflection. Let us execute the first type in reflection, which is the get type. So this particular example is based on get type. Here I provided the variable a, which stores the value 10. Then we are trying to get the type of a, and we'll be printing the output. Now let's execute this program and see the output. You can see the system has provided the type as int32. Now with this, let us move ahead and execute the next type of example, which is getAssembly. Now this particular example is based on getAssembly, where we have provided type t is equals to type of system.string. Now we'll get the getAssembly of this particular example. Let's execute this. You can see that the program has been executed and the type is private. Now let's move on to the next type and execute an example based on print type information. So this particular example is based on print type. So here we are providing different types, which is full name, base name, isClass, isEnum, isInterface. So once after we execute this program, we will be provided with the type of the function we are dealing with. Let's execute this program and see the output. You can see that the program has been executed successfully and we are provided with the types that we were using in our program. Now with this, let us execute another example based on print constructors. So this particular program is based on print constructors. So in this particular program, we'll be using a constructor, and once after we execute this program, the system will provide us with the constructor that we are using in this particular program. Let's execute this and see the output. So you can see that the program has been successfully compiled and the constructors which we are using in our particular program have been printed here. Now with this, let us move ahead. So this particular program is based on print methods. So we have certain methods in our program. So once we execute this program, we'll come to know which are the methods that we have included in our program. Let's execute this and see the output. So you can see that the program has been successfully compiled and these are the methods that we can use in our program. Now with this, let us move to another example where we'll be using the print fields function. So this particular program is based on print fields. Let us execute this and move ahead. You can see that the program has been successfully compiled and the fields have been printed here. So the field is system.string, which happens to be empty. So with this, we conclude the object-oriented programming of C#. Now we shall get into the advanced concepts of C#. We shall begin with anonymous functions. So what is an anonymous function? The function that lacks a specific name is called as an anonymous function. There are two types of anonymous functions available in C#. They are lambda expressions and anonymous methods. Now, let us execute a basic example based on anonymous functions. So this particular example is based on anonymous function. Now, we shall execute this and see the output. You can see that the program has been executed successfully and the output of the square area has been printed here. Followed by this, we shall execute another example based on anonymous method. So this particular example is based on anonymous method. So this function happens to be the anonymous function. Now let's execute the program. You can see that the program has been executed successfully and the output has been displayed. The message inside the anonymous function was, "This is an anonymous function." Now moving ahead, we shall understand multi-threading. So what exactly is multi-threading? Multi-threading is a process where multiple threads are created and assigned for different tasks. This saves time by executing multiple jobs at a single time. The multi-threading class is available in system.threading namespace. Each thread has a life cycle. The life cycle of a thread is defined in the system.threading.thread class. The following are the stages in a life cycle of any thread. They are unstarted, runnable, which is ready to run, then we have running, and then we have not runnable, and finally dead. Let us see some properties of threads along with their descriptions. Firstly, we have current thread, returns the instant of the currently executing thread. Then we have isAlive, which checks whether the current thread is alive or not. Then we have isBackground, which is used to get or set the value of the current thread. which is in the background or not. Then we have managed thread ID. It is used to get the unique ID from currently managed thread. Followed by that, we have name. Name is used to get or set the name of the current thread. Then we have priority, which is used to get or set the priority of the current thread. Then we have thread state, which is used to return the value of representing the thread state. Followed by this, we should look into the thread methods along with their descriptions. We have abort method, which is used to terminate the thread. It raises thread abort exception. Then we have interrupt method, which is used to interrupt a thread which is in wait sleep join state. Then we have join, which is used to block all the calling threads until this thread terminates. We have reset abort, which is used to cancel the abort request for the current thread. Then we have resume method. This is used to resume the suspended thread. It is obsolete. Sleep int 32. It is used to suspend the current thread for specified milliseconds. Then we have start, which changes the current state of the thread to runnable. Then we have suspend, which suspends the current thread if it is not suspended. It is obsolete. Then finally we have yield method. It is used to yield the execution of the current thread to another thread. We shall execute a real simple example based on multi-threading. So this particular program is based on multi-threading. Now let us execute this and see the output. So here thread T is the thread that we are using in our multi-threading program, and the name of our thread will be main thread. Now let us execute this. You can see that the program has been successfully executed and the thread name has been printed here, which was main thread. So followed by this, we shall advance into the next topic, which is exception handling. So what exactly is exception handling? Exception handling is a phase which deals with handling the errors and exceptions that arise in runtime due to the mistakes in code or invalid inputs entered by the user. In C#, we have 4 keywords in exception handling. They are try, catch, finally, and throw. Now let us execute a simple example based on exception handling. So this example is based on exception handling where we have a try block as well as a catch block. In case the try block fails, then we have the catch block which will execute the statements which are present inside that. Now let us execute and see this program's output. You can see that the program has been successfully executed and the exception has been printed here, which is none other than the divide by 0 exception, where we attempted to divide the element by 0. Now followed by this, we shall move ahead and understand different exceptions and their descriptions in C#. Firstly, we have system.divide by 0 exception, which is the error generated by dividing with the number 0. Then we have system.null reference exception, which handles the error generated by referencing the null object. Then we have system.invalidCast exception, which handles the error generated by invalid typecasting. Then we have system.inputOutput.io exception, which handles the input-output errors. Finally, we have system.fieldAccess exception. This is the error which is generated by invalid private or protected access. Now we shall understand the system exception constructors. The system exception constructor, which is used to initialize the new instance of the system exception class. Then we have system exception serialization info streaming context, which is used to initialize a new instance of the system exception class with serialized data. Then we have system exception string. It is used to initialize a new instance of system exception class with a specified error message. Then we have system exception string exception, which is used to initialize a new instance of the system exception class with a specified error message and a reference to the inner exception, that is the cause of this exception. Now moving ahead, we shall understand system exception properties. The first property is data. It is used to get a collection of key value pairs that provide additional user-defined information about the exception. Then we have help link, which is used to get or set link to the help file associated with this exception. Then we have hResult, which is used to get the set of hResult, a coded numerical value that is assigned to a specific exception. Then we have inner exception. It is used to get the exception instance that caused the current exception. We have message, which is used to get a message that describes the current exception. Followed by that, we have source, which is used to get or set the name of the application that causes the error. Followed by source, we have stack trace, which is used to get a string representation of the immediate frames on the call stack. And finally, we have target site, which is used to get the method that throws the current exception. Now we shall move ahead and understand system exception methods. So the first method is equal object, which is used to check the specified object is equal to the current object or not. Then we have finalize. It is used to free resources and perform cleanup operations. Followed by that, we have get base exception, which is used to get a root exception. Then we have get hash code, which is used to get the hash code. Followed by that, we have get object data serialization info streaming context, which is used to get the object data. Followed by that, we have get type. Get type is used to get the runtime type of the current instance. Followed by that, we have member-wise clone. It is used to create a shallow copy of the current object. And finally, we have toString, which is used to create and return a string representation of the current exception. With this, we shall execute few more examples based on exceptions. Firstly, we shall create a customized exception. Then we shall try to print the message. So this particular example is based on customized exception handling. Now we shall execute the example and understand how the exception works. So the exception here is the age should be more than 18. If the age is less than 18, then the message should be displayed which says, sorry, age is expected to be greater than 18. Now let's execute the program and see how does it work. You can see that the age I've provided in my program is less than 18, so the exception is been printed as invalid age exception, sorry, age is expected to be greater than 18. So this is how the customized exception works. Followed by this, we shall execute few more examples based on exception. Here we shall use finally block. Basically, we have a try block. Along with that, we will be having a catch block. In case if try and catch both fail, then we have a finally block which will be executed in the default case. Here you can see that the program has been successfully executed and the exception has been printed here which says divide by 0 exception. Now we shall move ahead and execute the last example based on exceptions, which is based on system exceptions. So this particular program is based on system exception. Now we shall try to execute this and see the exception thrown by the system. So here you can see the program has been successfully executed and the output has been displayed. The system exception is index out of range exception. So with this, let us advance to the next topic in our tutorial for today, which is synchronization. So what exactly is synchronization? Synchronization may be a technique that enables one thread to access one resource for a specific time. No alternative thread will interrupt until the appointed thread finishes the task. Let us execute a basic program based on synchronization to understand synchronization in a much better way. Firstly, let us see the functionality of a program without including the synchronization. So in this particular example, we will be executing the program without including the synchronization process. Let us run the program and see the output. You can see that both the threads are working together and the data is being displayed 2 times. Now let us try to execute the same example by including synchronization this time. So this particular program is based on synchronization where we have included synchronization on the same program. Now let's try to run this. Now you can see that the first thread will finish the process. After that, the next thread will be starting. So here, the system waits for the first thread to complete its process until and unless the second thread will not be started. So this is how we use synchronization in our real-time programming. Now with this, let us move ahead and understand the new features that are included in C#. Firstly, let us discuss the features that were in the C# 6.0. So the C# 6.0 had using static directive, exception filters, a wait in catch and finally blocks, auto property initializers, default value for getter only properties, expression bodied members, null propagator, string interpolation, name of operator, dictionary initializer, compiler as a service, which is Roslyn. Then we have a few more updates in C# 7.0, which are pattern matching, tuples, deconstruction, local functions, digital separator, binary literals, reference returns and locals, expression bodied constructors and finalizers, expression bodied getters and setters, out variables, generalized async return types. Followed by that, the latest upgrades in C# 7.1 are async main, default expressions. So moving ahead, we shall wind up this session with interview questions based on C#. So the important and most frequently asked interview questions based on C# will be found in this particular article, that is the top 50 interview questions you need to know based on C#, which is this particular article. So here you can find the interview questions based on 3 categories, which are beginner level, intermediate level and advanced level. Hope you go through this article and get to know some most important and frequently asked questions based on C#. So with this, we shall wind up this session. I hope you have understood C#, and if you have any queries related to this session or you need any codes to the program examples that we have executed in this particular tutorial, you can write to us in the comment section below and we will respond to you as soon as possible. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!